Good afternoon. I'm Padmaja. I'm a cloud consultant at KPMG. I'm here to talk about migrating Windows workloads to AWS. Before I do so, I would like to introduce my team and KPMG's migration to AWS. KPMG Cloud Transformation. Who are we? We are KPMG's public cloud owner. We are a team of 50 engineers and 10 consultants. We have over 500 workloads, over 300 production workloads, and we've completed over 50 migrations to AWS. We've been able to do this through our relationship with AWS. We are an alliance partner, and we have over 50 certified engineers. Our clients are both internal and external. KPMG's clientele includes enterprises of all size. Our business sells different solutions to these clients. We help our business leverage the cloud. For instance, we work with our management consulting team to build client due diligence solutions for banks. And we work with our risk consulting team on trader surveillance solutions. We also work directly with our clients. We help them build their cloud and DevOps capability. We take the experience of building the team internally, and we help our clients with their journey to the cloud. We also bring hands-on experience and all the battle scars that go with it. Majority of our applications are .NET applications. We use TeamCity and Octopus Deploy for building and deploying our .NET applications. We use Packer for building our machine images. We use Terraform and CloudFormation for building our stacks. So we build all our application, infrastructure, everything from code. And we use CI/CD pipelines for deploying. We use pull requests to control all the changes that go into these environments. Security, monitoring, and alerting is an integral part of the environments that we host. We work closely with our security team and service delivery teams to achieve this. These are the tools that we use internally. In addition to this, we bring in additional tools depending upon the client's tooling model. I talked about my team, the kind of tools that we work with, and the kind of work we do. Moving on to the next section, I'd like to talk about KPMG's mass migration. KPMG shut down one of its data centers. As a result, businesses had to move their applications to one of the public cloud providers or to KPMG's private cloud solution. We helped our clients with their business case for moving to AWS. We assess their architecture on-premise, and we build a similar or an optimized solution on AWS. And when clients are happy, we plan and execute that migration for them. AWS was a fitting choice because of the speed at which we were able to deliver. We had all our configuration, infrastructure, everything as code, and we had our CI/CD pipelines to manage that. Using these, we were able to build environments in a very quick manner. There are several factors that could accelerate a migration project. Today, when we say migration, organizations have begun to think in terms of 6 Rs. When we look at an application, we do the same thing. We look at the application, whether we want to rehost it, whether we want to retire it, retain it, maybe re-architect, repurchase, or re-platform it. We migrated several applications to AWS. We rehosted or re-platformed majority of the applications. Ideally, we wanted to re-architect or repurchase a lot of the applications because they could have benefited from it. But we couldn't do that for all the applications because of limitations such as we had a limited timeline to migrate to the cloud. And within that time, it was difficult for our businesses to organize their resources. For instance, one of the applications that we migrated, we found that majority of the team that built the application had moved to other parts of the organization. And the timeline did not allow the business to organize their budget and cost. So either we wait and then lose the application to a shutdown data center, or we move the application as is, and then on the cloud, once on the cloud, the business would get the time to organize their resources. Once we've decided on the migration type, we have to engage the right people, and then the right technologies, and then drive the project through the right process. This is key to a successful migration project, especially in an organization like KPMG, where process is very important. And this is what makes our applications secure and then comply with all the regulations. Then we try and look at focus on automation and then blueprints. Automation could be about automating the migration of the project to the cloud itself. Or it could be about identifying manual processes and then see what can be automated on the cloud. And then blueprints could be like identifying patterns which can be reused across migration projects. For example, a lot of the applications that we migrated had a very similar 3-tier architecture. We approached these applications using standardized network, compute, and storage modules. Another example would be, after completing 2 migration projects, we had a draft project plan which we templated on Jira. So using this, new migration projects could just clone the project and have a project plan from day 1. So moving on to migrating Microsoft workloads. Our workloads mostly consist of a SQL Server, a Windows Server, and Active Directory. I'm going to go through each of these components and then talk about how we migrated them to the cloud. When we provision an AD on AWS, a question we try to answer is whether we want to host the AD on an EC2 instance or whether we want to use directory services from AWS. Our recommendation is to use directory services for obvious reasons such as it's fully managed, and within minutes we have a AD configured and highly available. But we choose an implementation depending upon the client's requirements. If a project requires full control to the AD, then we go with implementing an AD on an EC2 instance. Otherwise, we choose Microsoft Active Directory from directory services. Once we've decided on the solution, we also we look at the AD itself. We identify the number of users, so it helps us decide the size of the AD. And then we engage security in these conversations. Because depending upon the project, we have to comply with certain requirements, the channel used for migrating the accounts, the post-migration task where they are mandatory. In addition to that, we follow the best practices where we migrate the accounts in batches, and we take regular backups so that we are able to roll back if something goes wrong. Once AD is sorted, then we have to look at the Windows Server. When we assess an application on premise, the first thing we look for is identify the type, whether it's a pet or a cattle. And then we look at the application hosted on the server and identify it as either stateful or stateless. We also look at the Windows version. We often find that on premise, the application is running on an older version of Windows, and migration is a good time to do this upgrade. And then we see whether this Windows upgrade is going to affect the application in any way. Then we try and see if there are any Snowflake servers. We don't want to go from managing a Snowflake server on-premise to managing a Snowflake server on cloud. We try and get rid of Snowflake servers. Then we also see whether the server is like public or private. If it's a public-facing server, we try to make it private by putting it behind an elastic load balancer, for instance, and make it more secure. When we go into a meeting with our clients and then clients tell us that they have an application on-premise, they want to move it to AWS, they tell us the CPU they want, the number of CPUs they want, the RAM they want, and then the storage they want. What they don't tell us is the nature of the application and then the servers. So we need to ask these questions to be able to architect on AWS for scalability and reliability. So once you've understood the server, you start migrating it to EC2 instances. The best practice is to go stateless and get rid of pets and replace them with cattle. But in reality, you're limited on time and then cost. And then often we are engaged in conversations with relevant teams which could prolong for a long time. And we could just lose the application to a shutdown data center. So what we do is in such cases, we just move the server assets to the cloud and then work out the modernization. So we end up dealing with pets on cloud. What are the problems that they present? So because the servers are manually configured, they suffer from configuration drift and eventually end up as Snowflake servers. And scaling is difficult because often we have to scale vertically rather than horizontally. And managing pets is difficult. Patching is often manual. We have to take regular backups of the server. And if a backup gets corrupted, our disaster and recovery plan is in trouble. But AWS has made it easy for us to manage pets on the cloud. It has all the tools and services which help us manage pets. Once we migrate pets to the cloud, we plug it with all the standard monitoring tools, SSM agent, and Lambda functions to care for them. Before SSM, we were using Jenkins for managing our pets. But since SSM, we've been using it for patching, configuring, and auditing them. And we use Lambda for taking EBS volumes, taking backups of our EBS volumes. We use maintenance windows and SSM documents for patching on a regular basis. As part of this process, we also send SNS alerts to our security team, for them, the patching status of the whole estate is very important. Although we are effectively able to manage pets on the cloud, over time, it becomes an overhead. The number of Lambda functions we have to manage grows. The number of SSM documents we have to version control grows. So we want to move to cattle. So when we identify a server as a cattle on-premise, the job becomes a lot easier because they can be configured as code. Unhealthy servers are just replaced with new ones. Servers can be scaled depending upon the demand and the load on the server. Adding a new server or removing old servers is just like configuring using code. No human intervention is required. And disaster recovery plan consists of recovering the whole environment and the application from code. Our standard CloudFormation template and Terraform module consists of these resources for provisioning a cattle. We use CloudWatch and autoscaling policies to scale the servers automatically. And then we use Elastic Load Balancer for load balancing. We use Web Application Firewall for locking down certain parts of the web service. And all this is done using our gold image, which comes from Packer. So managing cattle becomes easy. But to be able to architect a good solution for them, we need to ask several questions. We need to identify the application that's going to be hosted on the server and identify it as stateful or stateless. I'd like to give an example. So we were migrating this application. I'll call it Jenga. Jenga was a cattle when we first found it on premise. We were told that it's cattle. So we started migrating it to AWS. We had a dev environment on the cloud. And then we put Jenga there. And then we gave access to our application team who went and did some tests. And then the application team came to us and told us that Jenga is actually stateful. We were like, OK, it's fine. Let's just use Elastic Load Balancer, sticky sessions on it, and then move on with the project. What the sticky session does is it routes traffic to the same server depending upon the source IP. So it worked fine in the QA and then QA environments and the dev environment. And then we moved on to the next stage, the pre-production. And over here, we were scaling the servers up and down as part of testing for fault tolerance. And over here, we found that Jenga wasn't able to handle the sessions properly. And we were 2 days away from cutting over. So we had to move Jenga as an active passive server. And this was far from what we intended to do. In order to optimize time and cost and then avoid such design creeps, we have to understand the state of the application from the beginning. And now we know why I called it Jenga. Throughout the project, we were adding and removing blocks from it. A server could be cattle, and still it can be stateful or stateless. There are several ways to handle the session data on cloud. The popular solutions that we use are we use the sticky sessions on the Elastic Load Balancer, and we use a database or a DynamoDB. Implementing a database or a DynamoDB requires major changes to the application. And if time doesn't allow it, using the sticky sessions on the ELB is a quick option to move to the cloud. And once on the cloud, you can re-architect your application for handling your session data better. But the sticky session for ELB doesn't work well for applications with heavy traffic like the one with Jenga. So as the servers are become unhealthy and they're replaced with new ones, or they scale down, users will begin to experience glitches with their sessions. Cattle is easy to manage only if we take maximum advantage of code, automation, and orchestration. So we do everything. We don't give our developers access to the dev or the QA environments. They have to do everything through code. And all our patching is completely automated. We use SSM automation and Packer for patching. earlier, we had a dedicated resource whose responsibility was to make the gold image available. So whenever patches are available from Windows, he has to patch the base AMI and make the gold AMI available in the shared services account, which the project then have to go and pick up the gold AMI and then use it in their projects. We had several problems in this approach. Because our his job wasn't just like patching the AMIs, he had several other jobs, so he might be too busy for patching the AMI on time. And projects would often miss out on the latest AMI. So this is what we have in place now. We patch all our images using Packer. Packer shares the gold image in a shared services account while also sharing it with all the project accounts for it to be consumed. We version control the Packer templates, and we control all the changes that go into the gold image through pull requests. And we use Jenkins for orchestrating this workflow. So what has happened is we've completely automated the way we patch our images, and we version control our images. And we are working towards auditing how we are looking at how we can audit what goes into these images. At the moment, the only way we know what's going into the images is by looking at our scripts, and we are looking at how we can improve that. Moving on to SQL Server. When we start migrating a SQL Server from on-premise to the cloud, we always ask the question, why not RDS rather than why RDS? RDS is fully managed. It becomes too easy to set it up, operate, and then scale it. Once we've decided on the hosting, we plan and analyze the requirements for the data migration. We look into characteristics such as the size of the database, the engine version, compatibility, etc. We do a lot of tests. We need to load a sample of the data from on-premise on RDS to make sure that RDS is completely working. But a lot of the data that we work with are classified as confidential. So before we move that to AWS, we need to anonymize it using one of KPMG's recommended methods, and then get it signed off by our security team. And only then we can take that sample database to RDS. Then we plan our backup and recovery around our recovery point objective and recovery time objective. We use automated backups from AWS. We use database level backups as well. An important learning we take forward is to work closely with our DBAs. Our DBAs are like SQL experts, but they're new to working with RDS. It's very important to work with them and prepare them for RDS to make the data migration painless. As I mentioned earlier, AWS takes automated backups of the instance. In addition to the automated backups, we take database backups. We use Lambda function to do this. We have a standard Terraform module that deploys a set of Lambdas to all our AWS accounts with a SQL Server. What this Lambda function does is it uses SQL Server's native backup restore capability to backup and restore from an S3 bucket. We also have a Jenkins job that orchestrates this process, and we also give access to the Jenkins job to our application team, who use the Jenkins job to copy database from one server to another server without any dependency on us. This is an example of a simplified architecture of the application we migrated from on-premise to AWS. SQL Server, in-house built .NET application, which is hosted on a Windows server, a third-party reporting tool, which needs to be configured on a Windows server. On-premise, it was not scalable, and it wasn't highly available. To architect and move this application to AWS, ideally, we want to make this application resilient and reliable by re-architecting. As I mentioned earlier, due to limitations such as time and cost, we couldn't re-architect the whole stack. This is what we did, but we did make most advantage of the cloud. The SQL Server, we re-platformed it on RDS. The in-house built .NET application, we re-architected to be stateless and then scalable. The third-party reporting tool, we couldn't do much because we had a current license. We were on an older version. We didn't have the time to renew the license or change the license model. There was a huge process. So we just decided to move it as it. We rehosted it on AWS, and we are now working towards renewing our license and then upgrading the version or looking at alternative products. once on the cloud, we also shut down our dev and QA environments outside of business hours. And this was a big cost saving for the business from day one. We use single AZ RDS for dev and QA, and then a multi-AZ RDS in production. And all our servers were like spread across 3 availability zones to make it highly available. So we assessed the application on-premise, architected the environment on AWS, and tested the application using dummy data. So it should be time for us to migrate the actual data and then do the cutover. But it's not so easy. We have to engage the security and get their sign-off for this project. This is where what I mentioned earlier comes into picture again, people, process, and technology. Before we can move any production data to AWS, we need to get our environments pen-tested. And whatever issues are raised in the pen test, we need to resolve it, and then go for a re-pen test. Ideally, at this stage, all issues should have been resolved. If not, then a risk analysis is done, and a risk report is created, which goes to our quality and risk management team, who needs to accept the risk and sign off. If they don't, then we have to resolve the issues, and then go back into pen testing. So before we go pen testing, we need to comply with a lot of KPMG's best practices as well. We need to have Trend Micro deep security agents on all our servers. We need to have New Relic agents on all our servers for monitoring. We need to show our patching model. It's following this that we can migrate the data to AWS. So when we go for pen test, we have to secure our images, our application, and our AWS account. Our pen testers are going to look into all of these components. To reduce the time we spend with our pen testers, where we go back and forth with them resolving issues, we have to secure the environment before we go to them. So we start building the controls from day one. We do this using CIS benchmarks, KPMG's best practices. And then once we've implemented the controls, we use tools like AWS Config, AWS Trusted Advisor, and Inspector to detect the controls that are missing and validate the controls that we've implemented. Tapping into these tools, we have been able to speed up the process of getting an environment signed off, and have also made us confident about the environments that we build. We have an ongoing work stream where we try to code the implementation of these controls. So once the environment is signed off as secure, then we start planning the cutover. During cutover, we switch our users from an old server to the new server. We do this using during a cutover window or a regular maintenance window. A lot of the services that we migrated were live services, so we had to complete the cutover within the window. To ensure service continuity, we had to have a substantiated fallback and a support plan. Let's say if during the cutover window we couldn't complete the cutover, our fallback plan had to show what our alternative option is and how we are going to plan and execute a cutover again. In the case that we were able to successfully cutover, switch all our users from the old server to a new server, our support plan had to show how we are going to detect incidents and how we are going to handle them. We utilized Route 53 for DNS. We were already using Route 53 to route traffic to our on-premise servers. So this made it very easy for us because we did not have to rely on other teams for the switchover process. Also, before cutover, we selected a small pool of clients and used them to do some beta testing on our new server. Post-migration. Going forward, we want to retire our technical debt, review processes, and then optimize. We are working towards integrating KPMG's processes to adapt it to cloud. For instance, at the time of the migration, we used KPMG's change management process as is. This process works best for traditional services, but it's not the best for cloud. So we are working with our service delivery and release management team to try and adapt this process for cloud. From an optimization perspective, we want to make use of this. We want to make our environments more secure. We want to optimize the savings. We want to improve the performance. For instance, move from on-demand instances to spot and reserved instances. also working with integrating with KPMG's tools like ServiceNow. So at the moment, alerts are sent out as SNS alerts to as emails. We want to try and see how we can integrate it with our ServiceNow. So instead of having a person manually create the tickets, we have the tickets created automatically depending upon the incidents, and we're trying to see how we can avoid noise from this. Thank you for attending my talk today. I hope you found it useful. If you have any feedback or if you'd like to tell me how you do things differently, drop an email. If you enjoyed this sample of work we do, come join us. We are hiring. In addition to this migration work, we also do a lot of greenfield projects. Thank you.